Okay, so I'm going to be presenting number 7 on the angles assignment. So number 7 is about a tornado, thinking about it like a right circular cylinder. So, I mean, we know what a tornado should look like, right? It should look more like a cone, but we're going to oversimplify and pretend it just looks like a cylinder. So that way we can do some analysis on it, because a cylinder, we can look at it as a whole bunch of circles stacked on top of one another, and it's rotating the same way our wheel problem was rotating, so we can talk about linear speed. Okay, so for my numbers, it has a oh, and this is just the core of the tornado, right? So it actually may taper at the bottom, but we're just looking at a segment that is the core. At the core, the diameter is 280 feet. Okay, so here's my circle. 280 is the diameter. I know most of my formulas are going to involve radius. So at this point, I'm just going to say the radius is half the diameter, and I will be using 140 feet for my radius. And then they give me two speeds. They give me 240 miles per hour, which is equivalent to, they give this to me, I'm not computing it, 352 feet per second. 352 feet per second. So that's handy. It sounds like I'm going to have a choice which number is more advantageous to use, miles per hour units or feet per second units. So if I read ahead in the problem, it wants to know how many revolutions per minute. That's my goal. So if I think about which one's going to be more useful here, okay, neither one is in minutes, so let's not focus on the time. I want to be in miles or feet, and I want to be in feet because this radius measure is also in feet. So I think it's going to be advantageous to use the 352 feet per second. So that's going to be my starting value, 352 feet every 1 second, right? So I can always change a number into a fraction if I divide it by 1. Where are we heading? We're headed to revolutions per minute. So I think it's usually easiest to get the time units correct. So there are 60 seconds in 1 minute. I will cancel seconds, and now I have the right units of minutes. I still want to be in revolution, so I want the feet to cancel. So I'm going to be asking myself, how many feet are in 1 revolution? So this is my, it doesn't look like a circle, it looks like a football again. But if I revolve around once, so this is my start, go all the way back to that and end at the same place. 1 revolution is how many feet? So I can use my arc length formula that says S equals R theta, where theta is in radians. R is 140. Theta is once around the circle, 2 pi radians. So that's how many feet are in my revolution, 140 times 2 pi. So I'm going to replace this question mark with 280. If I just do the computation, 140 times 2, 280 pi. And my feet will cancel, and I'll have the correct units of revolutions per minute. So when I'm doing this computation in my calculator, 1 second here, I need to multiply 352 times 60 and then make sure 280 and pi are both in the denominator. Okay, so if I type this in, 352 times 60, make sure 280 and pi are in the denominator, I'm going to get approximately, maybe not the best picture, but about 24 revolutions per minute. Again, making sure that this is somewhat reasonable, okay? So this very large tornado is wrapping around itself 24 times every 1 minute, okay? You know, I think that's somewhat reasonable. I'm not getting a very small number, I'm not getting a negative number, I'm not getting an astronomically large number, okay? So hold that up there one more time if you want to pause on this shot, and then I'm ready to answer at 24 revolutions per minute. Okay, good luck on these.